Okay, so we'll get started. So we were talking about functions, right? So what we said is function is the name that we give to a block of code, right? So this is a block of code. And so this is called function declaration or definition. You're defining a function, okay? Function definition. Okay, it does not mean that you're calling the function. And when you call it, okay, that's when the block of code is executed. And you can call it multiple times, right? It need not be just one time. You can call it multiple times. Now, sometimes, okay, your function will take a value, right? So we are passing an argument, right? So if I say num1 comma num2, okay, then when I call this function, it's going to give me error. It says, okay, function one missing two required positional arguments. This is the key here. Key is, if you talk about functions, so we have required positional arguments. So arguments can be required and positional. What is required means? Required means that you have to provide value for this. There is no excuse. Okay, so if it takes two value num1, num2, you have to provide two values here. I can say 5, comma 10, right? So I have to provide the value. Okay, you have to provide the values for the arguments. Okay, and positional means the order of the arguments should match. Okay, so that means if I pass here num1 and num2, I have to pass two values. Let's say I'm passing 5 and 10. Then your num1, okay, will have 5. Num1 will get 5 and your num2 will get 2, because when you're passing the arguments, okay, when you're passing the values to the argument, first we are passing 5, so then we are passing 10, right? So it will go in same order. So 5 will go to num1 and 10 will go to num2. So when you run it, you get 5 and 10 here, right? So order also matters. That's why we say positional. Position also matches. Required, you have to give. Positional, okay, it has to be in the same order. Of course, you can print it, okay, or you want to return it. So I'm going to say total equal to num1 plus num2, and then you say return total. And here I'm going to catch it. Since it's returning a value, I can catch it like say result equal to, and I go here and I say print output is comma result, right? And now when I run it, okay, it is 10 plus 5, 15. All right. So this is how you can pass the values to the arguments, and then you can of course return it. Okay, and you can save it in a variable which you can use it for your later part of your program. Now, there has to be something opposite to required, non-required. There has to be something opposite to positional, non-positional, right? So if you want to be in a situation where the user doesn't have to give the value, okay? So the opposite of your required is called as default. Default value, okay? It's like your non-required value. Okay, so let's say I take this fun1, okay, and I put it here, and this time I'll make it multiplication, let's say. Now here too, okay, and I'll call it as fun2. I have to give different name, right? So now if I say result fun2, okay, and I'm going to say output func1 output. Func1 output, func2 output. Now, if I say func2 here, again, I have to give values for these two, right? If I give only one value, okay, it's going to throw error saying we expected one more value, okay, for num2. So now here you see it has taken value for num1. There are two arguments and we're passing one value. So Python is very clear which will take this. Num1 will take it because num1 is first. So num1 will take it. Num2 is second. So it's now num2 is waiting for second value, which it did not find, and it is giving error. Perfect. Now, let's say, okay, you want to have a situation where if num2 value is not passed, then you should take as 1. Okay, this is called non-required. Okay, so non-required means you are providing a default value. This is called default value for num2. Because see, in this case, I'm not providing value for num2. So num2 will take 1. Now, if I provide value 5, 10. So if you are providing the value, then it will take the value that you provide. But when you don't provide any value, it should take its own default value. Okay, so you see this. Okay, so you're in third last one, right? We said num1 5, num2 10, so it took 5 and 10, and answer is 50. But if you take this one, okay, we only gave num1, but we did not give num2. We did not give num2, so it took the value 1, which we have given as default. So this is called default arguments. Function with default arguments. Default arguments is the value that you give as default. So you say equal to something in the function definition, so that when you are passing the value, then if you give it, it will take what you give. So always the value that you give takes higher priority over the default one. When you don't give, that's when default one comes into picture. Very clear on this, right? So we have seen our function with required arguments, positional argument, and now default argument. Now, what is the opposite of default argument? Okay, so before we get into that, positional, default, there's one more thing that you have to understand. Now, if I have something like this, now let's say if I want to make num2 as default and num1 as default, let's say, and num2 as, okay, so I'll say func3, and I'll say num1 as default as, let's say, 10. And num2, I want to make it mandatory. This is, see, Python is already giving you error. PyCharm is already giving you error. This is not accepted. Because, see, we are talking about positional. Positional means first value goes to first one. Okay? So if this is required, this is the second value. So you have to give second value, isn't it? Only then num2 will get a value. Correct? You have to give value to second value have to be given. Otherwise, how will num2 get the value? So you cannot have, you can't have a train without last bogie. It's like this, right? You are saying that, train without a last bogie, whatever be the last one, that will be last bogie, right? So in this case, you get error.
So why this concept, Swapnil, did not work with the previous example? Like there we have given...
No. See, when I'm saying that I need second value, now let's say you say that I have to sit on second chair. Now, how can you sit on second chair without having the first chair? Correct? Yeah. So you can't have second chair without first chair. Then what's the point of giving default here? See, I have to pass two values here, isn't it? Because this is mandatory. So if I have to pass two values anyways, so there's no need to give default, isn't it? Yeah. Did you understand what I'm saying?
Yes.
Okay, a joke hai. Okay, so this guy, okay, was feeling hungry. He took idli and started crying after eating 5 idlis. So somebody asked him, why are you crying? He said, I'm a big fool. Okay. I took 5 idli, but I was full after eating the fifth one. If I had eaten the first itself, the fifth one, I would have saved 4 idli. जोक समझ में आया?
Say, yeah,
जोक समझ में, लेकिन ये समझ में नहीं आया, right?
yeah.
So if you have to give second value, then what's the point of not giving first value? See, why do we make it default? We make it default because you don't have to give the value for this. See, when you say num1 equal to 10, that means,
True.
okay, you tell me, how can you pass value to num2?
Yeah. We have to define the value over there.
I have to give second variable here. If I don't give 10, then this 5 will go to where? 5 will go to num1 only, no? To give value for num2, I have to give one more value. So if I have to give 2 values, then what's the point of making it 10? Tell me.
Correct.
Right? You're defining a default value which will never ever be useful. Isn't it? I'm saying that you have to give me 2,
Understood.
right? Then what's the point of having a default value? Okay, but first one is fine because you can, okay, first, making last default is fine because you can give it to first value, not give it to second value. But reverse is not possible. You have to give to first
Define the first
before you
value.
give the second.
Yeah.
Okay, so that's why. Okay, so that's why, okay, this is not allowed. You can have both default. If you have both default, okay, then I did not give value to any of this, right? If I don't give any value, it will take obviously the default 10 into 5. So when you run it, it will give you 50. Okay, so this is example of default, okay, but positional. But how to make non-positional? We call it keyword arguments. Okay, so keyword argument like non-positional. Okay, so what you do here, okay, see, for default, we were giving equal to in the function definition. Function definition, you are giving equal to. In non-positional or your keyword argument, you give equal to here itself, where when you're calling the function. Now I say here, num2 equal to 5. This is called keyword. Num2 equal to 15 and num1 equal to 99. So see, I'm using the exact name here. I have defined using num1 and num2. So I have to use same name here, but I'm using num2 first and num1 next. So if we are using the same argument name, then the order doesn't matter, position doesn't matter. We call it as keyword argument. This is your keyword. This keyword is same as the argument name. So if I say num2 equal to 15, now when you run it, okay, you see num2 is 15 and num1 is 99. So in this case, this order is not important. Order has not become important because I'm playing with the keyword here. So I'm using the same variable name which you have defined in function definition while calling the function. So whatever order you take, you say num2 equal to 15 and num1 equal to 19, your num1 will be 19 and num2 equal to 15. Okay, so when we actually when we use actual program, right, you will be seeing this a lot of times. Let's say you're drawing you want to plot a graph. To plot a graph, you need to have title, you need to have x-axis, you need to have y-axis, okay, all those things. But let's say you don't want to give. Okay, you don't want to give title, you don't want to give x-axis, you don't want to give y-axis. Then you have default values for all of those. Okay, so title will be blank default, x-axis will be blank default. So when you call plot, okay, and when you don't provide the value, it will take the default blank. And second thing is, now like same example, plotting, it will have 5 to 10 maybe kinds of variables. It wants to take title, subtitle, x-axis, y-axis, your label, right? So you might have to have multiple variables that you need to pass. Now to pass multiple variables, okay, to pass multiple variables, now let's say I want to give y-axis title, which is after 5 variables. So purposely I have to introduce, let's say what I'm trying to say is, okay, here I need to give num2 title, but I don't want to give num1. Okay, then says fine, don't give num1. Got stuck, what happened? Yeah, don't give num1. Now here only 2 variables are there, but you might have 8 variables. I want to give value to the 8th one, but I don't want to give value to 7, 6, 5, and 4. Then you use keyword argument. Then you use keyword arguments. Okay, but keyword arguments, again, you have to provide the value, default value, right, to the other. So that will be blank. So see, you can ignore the position. I'm not providing value for num1. I'm only providing value for num2. Okay, I said num2 15, so you got num2 15. All right, did you get it?
Yes.
So we actually use this function definition using these 4 types of arguments: keyword arguments, default arguments, your required arguments, and positional argument. Okay, and of course, like when you talk about actual use, you'll be using all 4 these together. Okay, so you will have a function. Okay, if you're defining it here, let's define it here. You will have a function like plotting a graph only. Plotting a graph, you need x-axis and y-axis. So you will have here, let's say x, y. Now in this case, what means? It means that you have to provide x and y in the same, like you have to provide the value. And rest of the value, you don't need to provide. Num3 equal to 25, num4 equal to 85, whatever, right? So now in this case, it's like mix of all the things. You have to provide xy value and you don't need to provide these values. So when I call function 4, I have to provide func4. Okay, so I have to provide xy value. Okay, not result. I have to call func4, right? So I'll call func4. I have to provide xy value 5, 6. But rest of the value I don't have to provide. It will take the default one. So this is how generally we use. Okay, you'll be using a mix of all these 4. Okay, while declaring and while using the function. Okay, so let's write a program. Let's do a couple of programs now. We'll write a program. Okay, I'll pause for 30 seconds. Let me know if you've understood this. Any questions here?
Saurabh,
Yeah.
I have a question. That return you are using there in define. So, what is the purpose of using that return? because we can get result anyways by print also, no, in last. So what is the use of return?
Okay. So the use of return is to get the result in your main program. Okay. So you're getting the result in the main program, and now it's up to you how you want to use it. You see, I can print it just like this here directly calling, or I might use this to do something else. I will say result equal to, so result equal to result into 10. So question is, whatever result you get, you multiply by 10. What is the 10 times the value of what you get? So when you return it, you have access to this value. You can do whatever you want to do. Now, in this case, I have no control over this, isn't it? But that's why we give return. So return, if you provide, when I say I can print it here, right? But when I print it here, I don't have much option. Okay, in the sense, if I print something like result is, output is, but I don't want to print output is, I want to print something else. I don't want to print only, I want to use it for something else, do something else, and then print it. Correct? So functions is okay. Let me be generic. Let me give you the result. Now you do whatever. You want to print it, you print it. You want to print it in, see, same function can be used to perform a total price. Right? I can say this is quantity and this is cost. So total price is. So in this case, I want to use it to display as total price. In some other case, this could be used for something else. I can use this for square also, right? I'll say n1 and n2 are same. I'll pass 5, 5. So I want to print as square. So you can be more creative. You can, in terms of using the output. But if I fix it, if I say print output is, then you can't change it. Every time you run the function, you'll get output is. Isn't it? You can't change the output. That's why it's always better you return the variable and you can print it. Here, I want to use it like function to output is. Here, I want to say function to result that we have is. I want to print the way I want to. But in this case, then I have to write same function 3 times, 10 times, right? With different stuff. So you have same function, but you are creative in the way you want to display the result. Understood? No.
Okay,
Yes.
so means this total till total it is only the function, and we have to use function and do whatever in function.
Calling, main.
Okay, while calling we can use anything, but
Yeah.
this is as a block we are using this total and return.
Exactly.
Okay, yeah, got it.
Okay. Okay. So now let's do a couple of programs. So we'll say write a function, and I'll show you this example only. I'll show you what I mean. Okay. So we'll write a function to check if a number is prime or not. Prime is not, yeah. Write a function to check, write a program. Okay, we'll say write a program only, WAP, and we can use function, that's our wish. Write a program to check if a number is prime or not. Okay, so I will write a function called, okay, def check prime, and this will take num, okay, and it will return whether prime or not, right? So let's assume that every number is a prime. So is prime equal to true? And I will return is prime. Okay. So this is the structure. We have not added the logic, of course, right? because you can't have every number prime, right? Now I can check here. So I can say, val1 equal to 15, val2 equal to 16, val3 equal to 17. Okay, now instead of, yeah. Now I'm going to say result equal to check prime val1, right? And I will say here print f val1 is okay. So now you see result could be either true or false, right? So I will check if result, then it is prime. Okay, is a prime number. Else is not a prime number. Not a prime number. It is val 1, 2, 3, right? Instead of doing this, what I can say, I can put a for loop here. For val 1 in a range 15, 16, 17 we want. So I'll say 15, 18. It's like same thing. So first val 1 will be 15, then val 2 will be 16, then val 1 will be 16, and then val 1 will be 17. So now if I run it, obviously all of them will be prime number, right? Because we have not added the logic. So we just defined a variable is prime and we are returning the prime. Okay. Now let's look at the logic here. The logic of prime number is you have to divide that number, okay, from 2 to, okay, n minus 1 or n by 2. Okay, need to check up to that. And if it has a perfect, divisible by any other number, then we say it is not a prime number. So if you take number 10 and we will check by dividing from 2 to 10 by 2 up to 5. So 2, 3, 4, 5. We'll check, we'll divide by 2, 3, 4, 5. And if it is perfectly divisible by any of these number, then it is not a prime. Okay. So here I'm going to check if num is less than 2, then we say is prime equal to false. If it is less than 2, it is false. If num is greater than 2, then we have to add our logic. Then we have to add our logic, right? So I'm saying pass 4 now. Okay. So it is pass 4 now. And then what is else? Obviously, else is equal to 2. So if it is 2, then is prime is true. 2 is a prime number, isn't it? So I'm saying is prime is true. So you have 3 conditions. Less than 2, it is not a prime. Okay. If it is more than 2, we have to check. If it is 2, it is true. 2, it is a okay, is a prime. So we say 2 is a prime. Perfect. Now, the logic here. So we will have to go from for I in range 2, comma, okay, the num divided by 2 plus 1. That means if you are giving me 50, I need to check from 2 to 50 by 2 plus 1, 26. 25 plus 1, 26. That means when I say for range 2, 26, that means I'm checking from 2 to 25. If it is 99, I'm checking from 2 to 25. Okay, if it is 101, I'm checking from 2 to 27. So if it is divisible by any of these number, Okay, so if for I in range, okay, num, okay, no, see this number has to be an integer number. A range should have integer number, right? So num divided by double divided 2 will give you, integer number. I'm adding 1 to it. Now, if your num modulo I equal to 0, that means it is perfectly divisible, then we will say is prime equal to false, and then you break it. We don't have to go any further. If you divide 99 by 2, okay, it is not divisible. Then you check both 3. If it is divisible with 3, that means it is not a prime number. You don't have to check any further, isn't it? Okay, you don't have to check any further. So you will say break. Okay, we found that it's not a prime number, and break. Okay, so now when you run it, see 15 is not a prime, 16 is not a prime, but 17 is a prime number. Did you understand this process? Tell me yes. You want to take time? Take time.
Is it necessary to have that num is smaller than 2?
Now smaller than 2. Where is smaller than 2?
First, num is smaller than 2.
Because see, you're checking from 2 to the rest, right? So better check. If it is less than 2, then don't even perform anything.
Okay.
Yes or no?
Yes, actually, previously when we have done for loop or if, then that time we have not used if num is smaller than 2.
See,
That's why.
ultimately, it is about getting the answer. Okay, if I don't do it, what happens?
I
See, if I don't give less than 2, okay, then what happens? Okay, now my objective here is to show you the function, right? You can go and check, you can later check this function and see if it is. See here also, I can say if not for 2 also, it will, this will also, if I say greater than 2 also, it will work. Okay, because when you say 2 comma 2, 2 comma 3, it will check for 2, right? So what I'm saying is, okay, so let's not worry about the function, the logic here. You can change the logic if you think, okay. See, ultimately, if you can reduce the number of lines, then it is better than my program. If you are not able to reduce the number of lines, then my program is better. Okay, I'm not saying that this is the best way to do it. There are different ways to do it also. You can put them in one single line as well. But point is, our focus is on function, right? So we are passing this num, and then this num is returning us is prime. So your question was, why not print here itself prime or not? Now, I will use same function to generate series of prime numbers between 5,000 and 10,000. So the next program is generate series of prime numbers between 5,000 and let's take 7,000. Okay, why to generate too big? Okay, this is 70,000, right? 7,000 between 5,000 and 7,000, or you can say 50,000 to 51,000. Let's generate prime numbers between 50,000 to 51,000. So I'm going to use same function. So if I had given here number is prime or not, I could not have used it. But now I can use the same thing. So I will write a for loop for I in range 50,000, comma, 51,001, right? 51,001 because I need to check from 50,000 to 51,000. So I have to go one step more. Now I will check. Okay, so I'll actually put this here and the print. Okay, so generate series of prime numbers between 50,000 and 51,000. Okay, now I will say here, if, no, first I have to pass this value. So I will say result equal to check prime I. And now I'm going to say if result is true, correct? Only then I will print, otherwise I will not print. I'll print what? I. And end equal to comma, so that it will be printed in same line. So I'm generating I from 50,000 to 50,001. I'm taking this I and passing it to check prime to see if it is prime or not. If the result is true, I'm printing it. If result is false, I'm not printing it. So these are your prime numbers between 50,000 and 51,000. 50,021, 50,023, 50,033, 50,047, 50,051. These are your prime numbers. You can check. And you see, same function I use to print whether the number is prime or not, and use it to generate series of prime numbers. If I had given a print statement here, then I could not have used at all for generating prime numbers. Yes or no?
Yeah, and that's the advantage of return.
Right. Always you should make it more generic. Okay, if you want to print it, you print it the way you want to print it. Get the logic done by your function, and then the output, display, printing should be done the way you want to do. All right. Tell me yes, we'll move ahead.
Yes.
Yes.
Yes. So now let's move ahead. Okay. So this is how you can use you can create your own function. Okay, you can have different types of arguments and you can return values. So the assignment is all the programs that you have done so far. Convert them into functions. Okay, so all your core logic should be in the function, and only the parameter or values to the argument should be passed to the function and the output displayed in the main function. So for example, I did one program, if you remember, for printing stars. So I said for I in range 5, for j in range 5, and we said print, right, and equal to space, and then after printing a row, we printed a blank line. So this will give us 5 into 5 stars, right? Now, in fact, this previous program, we should print, because you're printing in one single line, isn't it? Okay, so the last line is still waiting. So see, I've got only four lines of star. 5th star is end of this line. So I have to give a blank line so that it comes down to the next line. Okay. So this core logic, should we put it in a function? So I'm going to say def print pattern, and here I will take value that you want to print and number of iteration that you want to perform. So value num, right? And here you give num. Okay, here you give num, and here you print value. Okay, and then they call this here. So print pattern. Value that I want to print is, let's say this time I want to print hash, and I want to print 7. So you can print 7 hash. Okay, so you can use this. Okay, so something like that I want you to do for all your programs, so that you learn how to write a function. Make sense? You have a whole 1 week to do it. Find out 1 hour every day and write 2 functions at least every day. So you should have 10 functions for the next week, right? And next 2 weeks we are not meeting. Next 3 classes we will not be meeting, right? Okay, so this is how I want you to change your program. Okay, there's one more concept here called as global variable and local variable. Okay, now you see, now this num1, num2, I have to pass by calling the value, calling the function, then passing the value. Okay, now let me write one more function here. What I'll do, functions, all functions I'll write together because I wanted to show you something. Okay, so let's say I want to write another function here, def, and what is the function? I said local and global, right? So test. Okay, I'm going to say country equal to India, and I say print country is country. Okay, and I'll call this function here. Okay, we'll call it the last test. So it says country is India. Now, if I comment it, then what happens? Country is not defined, obviously, isn't it? Country is not defined. There's no value called country. So you say country equal to, yeah. Now, you can define something as globally. Globally means you define at the beginning, part of main program. I'm going to say country equal to India, let's say. Now, this is defined globally, correct? And this is called global variable, okay? When you declare a variable as part of your main program, it is called global. Now, I cannot be putting at the last because I told you it will check the order. So now country is available here. And when you define something inside, this is called local. So this is local to your function text. Always local will have precedence over global. precede global. So, okay, so when I run it, you still get small capital India, small case India, not capital India, because we have a local variable here. Now, when I comment it out, now when I run it, so see, global is there, so it's not giving error. Okay, so if you want local, you define the local variable and you use it. Okay, but if you comment it out, it still has access to the global. If I define in some different function, that it will not have access, but it has access to the global variable. Okay, variable India. Okay, great. Now, if I try to do same thing below, and I say country. So here I want to use global country. Here I want to use local. Now when you run it, it is giving error. Variable reference before assignment. So you are assigning the value to the country here, but you are using it before assignment. So since it has a variable, you have declared a variable here in this function, it will always look for the local, not the global. But let's say I want to use the global country here. Then you have to say global. Global keyword, I think this should help, I guess. Or maybe not like this. You say country equal, no. Okay. So if you want to use global, okay, you will say here global country. Now, when you say global country, now till you define your own value, it will use global country. Okay. So when you say global country, that means you're saying that I want to use global country, not the local one, because local is not referenced. Once you declare local, then local will be used no matter what you do. You cannot use global. But if you're declaring it later and you want to use global before that, you can put global and then you can use it like global. Okay. So this is difference between your local and global variable. Okay. All good so far? So, okay, always local will take precedence over global. Local will be used. But if you want to use global before declaring local, you can do it by importing it using global keyword. Okay, global is a keyword. You cannot use global as your variables. Okay. Okay. Now there is one more type of function we will do. This is called as variable length arguments. So far, all the functions that you have done, whether it is positional or keyword, required or default, the number of arguments were fixed. Whether you do 2, 3, 4, or 5 or 100, you have to, it is fixed, right? In the arguments you say 100, then you'll be able to use only 100. Now we're talking about a situation where you don't know how many values user will enter. So it's like a flexible bag. Okay. So it's like, foldable bag that you have, right? If you have one thing, just unfold it, remove one layer of zip, it becomes small bag. Remove one more layer of zip, it becomes bigger. Remove one more zip, it becomes bigger, even bigger. That is your variable size bag. You can change the size of your bag based on the data. If you're handling small data, you just open one bag. Or, okay, in function definition, okay, so I'm going to do this. I'm going to define a function. So define var len demo or something I'm going to call it. So where it's like a normal function, variable length arguments function. Okay, doesn't look any different, right? Okay, doesn't look any different because there is no difference as such. We haven't done anything which will make it different. Okay, now I will go here and I will say that your function will need one required argument and one names, let's say, one variable length argument. Now, variable length arguments is defined or used using star or double star. Favorite or something I call this. Okay, so now I'm going to say here print names, comma, names. Print favorites equal to favorite. Okay. Now what happens here? These are variable length. Variable lengths are using star and double star. Okay. So when you are using star here in the variable length, in the arguments, it means it's a variable length. It can have values starting from 0 to anything. Okay. Here also it means 0 to anything. But what is the difference between star and double star? I'll show you here. Now I'm going to call this. Now see here, when I run it, this is going to give error, right? Because we have given num. So num has to be there, right? I need to pass 100. At least one value for this num. This is compulsory. This does not have star. This does not have star and there's no default value associated. That means you have to pass value, isn't it? So I'm passing 100 to this. Now you see names and favorite. What do you notice here? What do you notice here? How his name got printed?
As tuple and favorite as a dictionary.
Correct. This single star is read as a tuple, and your double star will be read as a dictionary. Dictionary will have key and value pair. So it is expecting us to give key and value pair for favorite and tuple, okay, for names. So since we do not provide anything, okay, it is given us names and this. Now I can say something like this. If len of num, not num, len of names, okay, so is greater than 0, only then you print names. Okay. Similarly, I will say if length of favorite is greater than 0, only then you print favorites. So now when I run it, you see, it is not printing num and favorite anymore because the len is 0. There's no element in it, len is 0. So it is printing 0 for us. Right? Now I can pass some value to it. So second time I'm calling and I'm passing, let's say 11 here. And now I'll pass for names, right? So you can enter anything, right? The tuple can have anything. Let me put some names here. Sachin, Virat, Rohit, MS. Now when you run it, len of tuple is definitely more than 0. So it printed these values here. And of course, when you print, when you read a tuple, you can use it like a tuple, you can use it. Right? So this is how you provide flexible number of values. Okay, so here I have provided only to the star. And you can have 1, 0, many. Okay, there is no restriction as such. Okay, now I can provide value to something like this. So I can say color equal to blue. Okay, game. Oh, sorry. This keyword will be without quotation, right? If you remember the keywords that we added in the function, we use variable names where okay. So this variable names when calling function 4 we called, right? Or where did we call this? Yeah, here. So num2 is not in quotation. Okay, left side values is like a variable. So it will not be in quotations. It's here also left side color blue, game equal to, let's say, badminton. Okay. Drink equal to water, right? So now when you run it, you have three values. Okay. And say we will say equal to here, like keyword arguments will be read as a dictionary. Keyword arguments will be read as a dictionary. Key is your keyword and value is your value. Right? Now, I cannot say here, comma, maybe what? Pandya. I cannot say like this. Why? Because we have written star first, double star later. So I can only give values to the tuple first and then values to the dictionary later. I cannot again use tuple, right? But what I can do is I can choose not to give value for tuple. I can choose not to give value for tuple. So tuple will be empty, but I cannot give tuple outside after this double star thing, after dictionary thing, because star one will go first, double star is later. So this is error. Okay, this is error, obviously. This is also error. Okay, it says positional argument, right? If I delete it, now it's fine. Now it's fine because your tuple will be 0. Tuple is not displayed directly, dictionary is displayed. So this is called your variable length arguments. Recording. So the next concept we'll talk about is called recursion. Okay, recursion is calling the function calling itself. Okay, so you have function calling itself. So let's say I have a function called def recursion1. Okay, and I say print how are you, right? Now, if this function calls itself recursion1, so recursion1 is calling recursion1. So what happens? Okay, when I call recursion1, it calls recursion1, then it prints how are you, then again it calls itself. Again prints how are you, again it calls itself. So it goes into what we call as infinite kind of recursion. Okay, so it went, okay, after 999 times, it says, okay, I can't go any further. Okay, so this type of situation is called recursion, and this is very helpful. Sometimes we need to do it. Now, obviously, this is not how we implement it because it goes into recursion, like infinite loop, right? Function calling itself goes into infinite calling. So instead of just calling itself, it should have at least one stopping condition. It should have at least one stopping condition, isn't it? That means you have so it's like if you want to perform recursion, it should end before 993 times. Otherwise, if you don't stop it before 993 times, it goes into the error stage, isn't it? So there are some situations, okay, where recursion is useful. For example, you talk about, let's say, factorial of a number, right? So if I take a factorial of a number, let's say factorial of 5, I calculate. So what is factorial of 5? It is 5 factorial. This is how we write. Now 5 factorial is same as 5 into 4 factorial, isn't it? It is same as 5 into 4 into 3 factorial. That means the logic of writing a factorial is recursion. 5 factorial is same as 4 factorial. So instead, if I say here factorial, factor recursion, and if I pass n, now this is same as saying n into factor recursion n minus 1, correct? And here, let's say if I pass 5. So this is a case, this is a recursion case where I'm saying recursion 5 is 5 into 4 factorial. 5 into, no, recursion 4. It will go on like 5 into 4, 4 into 3, so on. But you have to stop somewhere. Recursion should always have at least one stop condition. In this case, if n equal to 1, that's when we stop, isn't it? We say return 1, because when you get 1 factorial is 1 only. Okay, 1 factorial is 1, or you can say 0 factorial. You can say 0 into 1. And that's when you stop, isn't it? And this is what you return now. So now if I say result equal to, I will get the recursion value. Okay, I want you to do this assignment, one assignment. Use recursion to calculate sum of first n natural numbers. Same concept. So, okay, so you say factorial n is what? N into factorial 4. And you need to have at least one stopping condition. If you don't have the stopping condition, it will go on forever. We can't go on forever, isn't it? We need to have at least one recursion. So that's when you will stop here. Did you understand? Okay, we did not run it, right? We need to run it. So, it's still printing 5,000. Yeah. Oops. See, anyway, I have saved this here, so I can delete it. I have, my system has become slow here. One second. I don't know why. When I remove the power cable, it becomes slow. So I remove the power cable just now, it's fully charged. It becomes slow. Let me put it back again. Okay, now you should be able to see here. Factorial is 120, right? Factorial of 5 is 120. All good? Now let's talk about what is,
Saurabh, I'm not able to understand this one.
tell me what you didn't understand.
Why you have given this if n is equal to 0 and return 1?
See, when you say a 5 factorial is 5 into 4, 4 factorial 5 into 3, 4 into 3 factorial. So that you after some time you will get 5 into 4 in, okay, you will say 2 factorial is 2 into 1 factorial, correct? What is 1 factorial? So 1 factorial is 1 into 0 factorial, right? What is 0 factorial? You cannot say 0 into minus 1 factorial, right? That's not right. 0 factorial is 1. So that's what I'm saying. I'm saying if it is not 0, do this. If it is 0, then you stop 1. Okay, there is no, that logic doesn't continue beyond 0. Logic of n factorial is n into n minus 1 factorial doesn't. So factorial is what? 5 factorial is 5 into 4 factorial. That is, I'm saying n factorial is n into n minus 1 factorial. But this does not apply for 0. When you get 0, n is 0, then you return as 1. 0 factorial is 1. 0 factorial is not 0 into minus 1 factorial. Did you understand? 0 factorial is not 0 into 1 minus 1 factorial. 0 factorial is 1 only.
Okay.
That's why I'm saying when it is 0, then don't perform this. Instead, return 1 and stop. Okay, so your recursion should have at least one stopping function. Okay, so the last concept which I want to talk about is called module. Module is nothing but collection of function. We discussed that. We used random module a couple of days back, right? In random module, we found like we were doing we were generating random values, right? So you had rand there, rand in there, rand choice there. So module is nothing but it's a file name which has multiple functions. Okay, so this has multiple functions. So this we can use it like a module. Module is collection of functions. So we have functions like func1, func2, func3, func4, test, okay, varlen demo, okay, your check prime, okay, test. These are factor. These are all functions. Now, if your file has these functions, okay, let's say I have developed these functions and I want, I have developed this function and you want to use these functions. Okay, you feel these functions are useful to you. You want to directly use it. Just like random module, right? So we call it as module. That means this file name, which has all these functions, prog1 is your module. So if you want to use this, you can simply say import prog1. That means prog1 is a file which has all the functions and all, you just say import prog1 and all the functions of prog1 is now available to you for use. I can say prog1 dot. So see, this is a variable, result is a variable. You have test, func4, func1, okay, factor recursion, factor2, factor. These are all functions which are available, which we wrote. Functions and variables both are available for us to use. Val1 is the variable, check prime is the function. All these functions are available. Okay, this is called module. Module is a collection of functions which you can use them. You don't have to copy and paste. Okay, you simply use them. So most of the time what we do, we write a file, we put all our functions there and some other file we call it. Now let's say this prog1 I did it, okay, and you want to use this for your purpose. So you will go here and say prog1, import prog1, right? Now when I say June 2023, you see that prog1 file is run. I want to import the functions only. I don't want to import everything. 100% of the time, you will want to use functions. You don't want to use all the work that I have done because you want to reuse the function. You don't want to reuse my work, right? You have your own plans to use this function. So there is a way whenever you are doing a program, whenever you're doing Python program, okay, what you do, you put all your functions together above. So, right, this is a function. I'm going to take it. And this is a factor. I'm going to take this. And I'm going to go up. This is check prime. So I'm going to take this also. All the functions you take and go up and put them all together. So if you see before this, these are all functions only, right? Global variable or functions. Okay. After this, once you are done doing the function, when you are doing any work, and this is your habit. This should be your habit from today onwards. When you do any Python program, you should put all your functions there and all the calling things, all the main should be below here, right? And what you do here in this case is, okay, you put something like what we call as if, okay, you will have this way, okay? So we say if name equal to main. If name equal to main, then you perform all this. If name equal to main, only then you perform all these. Okay, all these are part of this condition. What does this condition mean? Condition means, okay, name means the module or the file in which you are running the program. So when I right click here and run from here, that means the main program is this file, prog1. So name equal to main will be true in this case. That means I'm running this file. So this is true and entire thing will be called. Now, when I go to June, where I'm saying import prog, but I'm calling June. When I call June, what happened? This is main. This is main program, not prog1. So this condition becomes false and none of these are executed. So from now on, when you're doing your programming, whether you're writing functions, which we have seen today, or you're writing class and object that we will see in the next session, you should put it first, all of them, and have this if name equal to main, and then you keep putting stuff here. With me, everyone? Always have this name equal to. That means if I run this program directly, only then these things will be called. If you import this file somewhere else and you run it, those things will not be called because name in this case, this June is your main program, not prog1. So the content of prog1 is not even called. Your functions are available. Your functions are available. So prog1 dot, your functions are available. Function 4. Okay, function 4 is available. I say 10, 15. Print prog 1 dot function 4 10, 15. It will print the output of the factorial only. It is not going to print all the things that I have done. With me?
Yes.
This is called writing or creating a module. Okay, module is nothing but it's a simple file name, prog1. We did that program in prog1. So prog1 became module 1. Okay, so prog1 becomes module 1 and you just have to say import prog1 and all the content of prog1 is now available to you for using. And when you're writing a module, just make sure that you put name equal to main, so that when others call your module, these things are not called, because these things are my personal stuff, right? You won't be interested. You will be interested in doing your work, but you want the function which I have used for your own purpose, right? So when we call random.randint, we wanted it to generate integer value. We don't want to know what all things, you know, the developer of random did there. So that's the beauty of this. With me? Okay. So this is called module. Okay. And we do create module here. Now there is one more thing called docstring. Docstring is giving documentation to the function. So when I say I write a function here, so in the function, your very first line multi-comment is called a docstring. Just it should be exactly below def. If you write somewhere else in the program, then it is not called. It should be within the check prime here. So you say this function takes a parameter and checks if it's a prime or not. So parameter number to check, return true or false. Okay. This is called documentation. So what happens is, and this is always a good practice. So what happens if I want to use this check prime? So before using check prime, I want to see the purpose of check prime. Is it something which I need to use or not? So for example, I go here and I say prog1 dot check prime, right? But before I use it, I can check the documentation of it, isn't it? So I will not put this bracket open and close, and I will say instead underscore underscore doc underscore. Name underscore you have seen, main underscore you have seen. Now this is doc underscore underscore doc underscore. See, whenever you see a value with double underscore something double underscore, both front and back double underscore, important. Front and back double underscore, that means these have predefined meaning. These have predefined meaning. So doc, okay, we call it docstring underscore underscore doc underscore underscore. This will give you the documentation, which is the first multi-line comment after def keyword. Okay, it's no hash. It has to be multi-line. That means either you use triple quote, triple single quote, or you use triple double quote. Okay, nothing else. So now if I print it, okay, so whatever you have given there will be printed here. See, this function takes a parameter and checks if it's prime or not. Param number to check, return true or false. Whatever you write is printed here. Okay, and every functions have this. Now, if you talk about len, okay, len is an inbuilt function, right? Len dot underscore underscore doc underscore. It will tell you the documentation of len. This is the documentation of len. Returns the number of items in a container. I want to know the input documentation. And so I'll say input. All functions will have it. Okay. So when you write your function, you should also write docstring. So this is the complete docstring of your input. Read a string from standard input. The trailing new line is stripped. The prompt string, if given, is printed to standard output without a trailing new line before reading input. The user hits end of file. Okay, on, you know, this is Windows Control D or Control Z written raises end of file error. On Unix systems, read line is used if available. Right? So this is the documentation which the developer of input has written there. So whenever you write a function, you have to write this documentation so that if somebody else is using it tomorrow, if you only want to see why did I write this function, what does this function do, you will forget. So, you know, better you write documentation which will help you to understand and refer in future. All right. Okay, so with this, we finish our discussion on. So we spoke about modules so far because we only covered function. We also have packages. Packages are folders. Okay, so you'll have a folder. Inside that folder, you will have multiple modules or multiple files. Okay, so for example, just give me a second. C users HP PyCharm project. Okay, so now I'll show you this file. This is a structure, okay? Now what I will do here, I'm going to create, I'll call my package, my pack 3. You see pack 1 and 2, already the packages have been created. So you have my pack 3. Okay, so my pack 3 is a folder and I'm going to copy P2, right? No, prog1. Sorry, prog1. I'll take prog1 and what I'll do is I will take P1 also. Okay, let's say prog1 and P1. Prog1 and P1. I copy this and I move to my pack 3. So my pack 3 is a folder which has P1 and P2 modules. See, module is one single file and package is a folder. Now, how do you say that this is a package? And package I will be talking about after doing the class, because modules can have class and objects also. Okay, so here I will create one more Python file and I'll call this as underscore underscore init underscore underscore. Okay, underscore underscore init underscore. So this file should be there and this file should be blank. So I'll open this, not should be, can be blank. So this is blank anyway. So what I did, I created a folder called mypack3. Inside mypack3, I have init and I have P1 and P1 and prog1. Now let's go back to PyCharm. When you come back to PyCharm, here you see you have mypack3 which we created. And in mypack3, we added init, because of which you see a circle here, indicating that it's a package. So mypack3 has init, P1, prog1, P1. So what I'll do, I will copy some dummy functions in prog1 also. This is mypack3/P1. So I will add some dummy. So dummy1 function, print nothing. Okay, def dummy2, okay, colon, I missed it, print, I'll say dummy2. Okay, so you say colon. So far what did I do? I created a folder and in folder I created the blank init underscore underscore init underscore underscore to indicate that it's a package, and then I added two different files, prog1 and P1, and they have functions. So now when you use this, when you come to June here, I will say import, what is the package name? mypack3. You see, mypack3. Now mypack3 dot what? Okay, so dot mypack3 is a package. So dot nothing is there. So I will say import mypack3. Okay, now or I can say here from mypack3. Okay, so two ways. Okay, so one, you can say import mypack3 dot prog1. Okay, so import mypack3 dot prog1. So prog1 is only imported here. I can give an alias as mp1, let's say. Now when you say mp1 dot, you can see all these functions available here. Okay, or second method is you say from mypack3 import P1, and now you will see P1 dot dummy1 dummy2. Okay, So you can have a folder. Folder can have multiple modules. You can have a modules which modules will have multiple classes and multiple functions. So the date time is actually a module which has classes, and I'll talk about it. Classes will have functions. So once we do classes, we'll come back and we'll discuss what is date time.
Okay.
So date time is also a module which has a file called date time, and that file will have multiple classes actually. So if I create P18, okay, P18 has some data. P1, let's say this is different P1. Here I go and I say class 1. Okay, pass. Okay, class 2, I'll say pass. Class 3, I'll say pass. Now we have not done classes. I'm not writing this, but this class can have function. So now when you go to June this, and when you say import P1, right? Import P1 dot, you see class 1, 2, 3. Okay. So your date time, those are your classes in datetime module. So datetime is a module which has multiple classes.
Okay.
Okay. Yes. Any other question?
Nothing from my side.
Perfect then. If no questions, we'll end it here for today. And when we meet, we will start with class and objects. So I told you class and objects is minimum stuff. Okay. So with class and objects, you would have completed almost like 75%, 70% you can say of our content. Then we'll take extra 3-4 topics and we'll finish off.